everyone. We are the team Tarang. I am Anirjith.
And I'm Chiranth. We are studying in grade 8 at ATL Public School, Koorgalli, Mysore.
The theme we have chosen is agriculture, and the problem statement is design and construct a device or an instrument capable of identifying and measuring the levels of pesticides or other chemical residues present in soil and food products, thereby verifying their organic status.
Our project aims to create a device that would help organic certification agencies identify the presence of pesticides in soil samples.
We can determine the presence of pesticides in a soil sample using various technologies like gas chromatography, mass spectroscopy, liquid chromatography, mass spectroscopy, and spectroscopy. Our solution is a low-cost spectrophotometer which is designed to be a cost-effective and a practical tool specifically tailored to assess organic certification bodies to determine the presence of pesticide residues in soil samples. This innovative spectrophotometer utilizes a combination of a light source, gratings, webcam, and the spectrometer software to determine the presence of pesticide in soil samples. The device offers real-time data analysis capabilities, empowering them with timely information to make informed decisions about the organic status of the crops.
The World Health Organization reports that pesticide exposure causes an estimated 200,000 deaths each year globally. The main components of this low-cost spectrophotometer include a wooden box, a webcam, a diffraction grating, glass cuvettes, and a light source.
The wooden box holds the webcam, cuvette holder, and grating.
A standard webcam is repurposed as the optical sensor for the spectrophotometer. The webcam is placed at a 30-degree angle that captures light transmitted through the sample, enabling the device to measure the absorption characteristics of the sample solution.
A diffraction grating 15,000 lines per inch is incorporated into the spectrophotometer to disperse the light into its components.
The software we have used is their monospectrometer tool for spectrum analyzer available free online.
We used two soil samples, one garden soil from our school and the other was collected from an agricultural land where the crops were treated with glyphosate pesticide.
We tested the soil samples for the presence of glyphosate pesticide. The procedure we followed for the test is given in the flowchart. The results are as follows. Without pesticide, the reading peak was 412 nm, and with pesticide was two peaks, 412 nm and 476 nm.
I am Anirjith. I worked on the model and experimentation. I also helped in documentation.
I, Chiranth, worked on the software, documentation, and research. I helped in building the model too. Thank you.